space-time. Someone I covered that in the last couple times, and people had some comments about it. So let's review some of that because it leads to the subject matter today, which is weight, which has to do with
Oh,
special
true. Yeah,
relativity.
let's not forget about weight.
Okay, so here it is in physics.
Real quick before you start,
Yeah.
what if you typed in rope hypothesis stuff into the AI and says, "Hey, this actually is the best theory"? Then would you be like,
No,
maybe there's something to this?
no, that would be an opinion. And robots don't
Well,
give
no,
opinions
because
unless we put it in there.
I don't know.
Okay, look, so this fellow says, in physics, horror of vacui, or plenism, commonly stated as nature of horror is a vacuum, okay? It came out of people like Aristotle, right? Vacuum energy is an underlying background. So he believes space, right, is made out of energy or filled with energy. I don't know what the difference is there. I mean, is space the same thing as energy? Is space filled with energy? If it's filled with energy, you're saying that space is a container, and I want you to draw this container for me. Otherwise, you can't say it's a container that energy fills.
Well, is it just me, or did he make a mistake where he's saying vacuum energy? He's saying whenever there's a vacuum, the vacuum sucks everything in. Well, but really what's happening is the pressure of everything is pushing stuff into the vacuum.
No, but here he says it in the next line. Energy that exists in space throughout the entire universe.
That sentence doesn't mean anything.
It means a lot, because what the fellow is saying is the universe, space, whatever, vacuum, whatever you want to call it. I don't care what you call it. Nothing, call it nothing. Vacuum. Whatever you want to call that nothing, that black stuff between the earth and the moon, he's saying it's a physical object. It's a container. And it's filled completely with energy.
With vacuum energy.
Yeah.
But why is he saying that? Like I said, I
because
think he got
people have this
wrong.
nonsense.
But what I mean is, I think he got something wrong, because he's saying that whenever there's a vacuum, whenever there's nothing there,
there's still energy.
Yeah, but he's saying that the energy in the vacuum, whatever the fuck that means, is pulling everything in. But really what's happening
But that's not the point. We don't get to pulling yet.
What?
The guy is already giving an assumption. He's making an assumption, a hypothesis. His assumption is that space is a physical object. It's a container. Yeah. Okay, it's a container. I mean, a container has sides to it. Means we don't know what's on the outside of that. That's something he's got to tell us, right? What's on the outside of the container, giving shape to the container. But he's saying the container inside, every bit of it, which he calls space, is filled with this so-called energy. What does that mean? Mean that space and energy are one and the same. Okay, because he's saying that every bit of space is filled with energy, meaning space and energy is the same thing. Or you could, I don't know if you can change that in any way, because see, when you have a container and you put gas in it, it doesn't fill every bit of what's inside the container, which is the nothingness. But this fellow says that every bit is filled inside with this whatever thing energy is. That means energy and space are the same thing. The container itself is energy, and all we need to know is what's on the outside giving shape to this container. Okay? So you cannot say the universe is filled everywhere with energy, because all you did was leave the container, the notion of container, to God or whatever. You're not explaining what the universe is. What is the universe? Is it a container? Is it a box? A sphere? What is what's the shape of the universe? What's the shape of space? That's what you got to tell us if you're going to treat it as a physical object, as a container. And if you say, well, it's infinite, then it's not a container. Yeah. Okay? It's not a container, it's a concept, because no object is infinite. All objects are finite. You're talking about a concept, okay? And so you can't have it both ways. Either it's a container with shape, or it's a concept, in which case you cannot say we live inside a concept. We live inside a box that is not a box, that is love, that is thought, space, or anything else.
Space, according to you, is a concept, right?
Space is nothing. Right, which is a concept, but we don't live within a concept. Yeah. Okay, it's not like I go to the end of space and find a wall there. So space is a concept because it's nothing. Yeah. The only thing that exists are the things, the atoms, the planets, the asteroids, the stars that exist. Those are the objects, right? But you cannot say we live within space or within the universe, because space, universe, vacuum, concepts. The word is nothing, and nothing is that which doesn't have shape, which is the opposite of a thing, which is the opposite of an object.
I mean, I think again the problem becomes all this semantic stuff, where it becomes hard to talk scientifically
unless you define your terms.
But not just that, but like if you, it's hard to speak without metaphor. It's almost impossible.
Well, unless you define your terms.
Even then, it's like a minefield.
No, it ain't.
It is.
I like to define terms. That way we know exactly.
Yeah.
But people don't realize the importance of defining word. They say, oh, that's word salad. Oh, that's semantic.
You know what I mean. No.
No, I don't. And so this fellow absolutely says that he sees nothing. And I agree with him. He sees nothing. Okay, the vacuum energy is a special case of 0-point energy that relates to the quantum vacuum. Whatever he said there, I don't know. The effects of vacuum energy can be experimentally observed. So he can observe the vacuum. He can observe nothing, and I agree with there completely with him. He observes nothing. Okay, he can see nothing. Okay, so here we have the fellow who allegedly is a physicist. And now he's really, in my opinion, just a bozo. He's not a scientist, but he's in the entertainment business, really. And some of you seen him around. If I can put him in here.
We really got to ban the word energy, don't we?
Yeah. His name is Siegel, Ethan Siegel. Some of you probably know him, and here it is. And he says, 70-year-old quantum prediction comes true as something is created from nothing. Okay, so he says, in our common experience, you can't get something for nothing. In our quantum realm, something really can emerge from nothing. And he goes in there and tells you how particles and antiparticles come in from the void. Okay, so he goes through that rigmarole telling you that, and then he explains the mechanism. He goes in there and says,
what's the mechanism?
Here's the mechanism.
There's nothing, and then there's something.
Here's the mechanism. He says, let's imagine we got very, very strong electric field. That's a nothing, I guess, right? So we're going to start with an electric field. He's going to call that nothing. Stronger than anything we would ever hope to make on Earth. The quantum vacuum in this region of space is going to be extremely strongly polarized. The quantum vacuum, the nothing.
Vacuum is polarized.
Yeah, he's saying that this field is nothing. It's a quantum vacuum, but it's polarized.
What the fuck?
So again, they contradict themselves, and it's all word salad. It's all semantics that these people get tangled, in their own semantics. Strong polarization means strong separation between positive and negative charges. How those came out to be, I don't know. I thought we said there's nothing there. Okay, we're talking about the vacuum.
Charges are there, but nothing's there.
But not the vacuum. It's the vacuum. Nothing is there, but we have charges. Whatever charges are, whatever field is, we have something.
We're just throwing words out.
Yeah. If your electric field in a region of space is strong enough, blah, 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 okay? And so he goes in and says, that's what the Schwinger effect is. Unsurprisingly, it's never been observed in a laboratory. No kidding.
How do you observe the polarization of nothing?
So it's like this other fellow who's, trying to see nothing, so... I don't know how these people really try to make sense of this when they're saying, look, we have this vacuum. This is their argument. They say we have vacuum, okay? And in that vacuum, we have fields.
Okay.
Well, what do you mean you have a field? What is a field? Is it a something or a nothing? And so, they treat it as a concept, but they're also treating it as an object because it says the vacuum has fields, whatever fields is. And then they say there's charges in there. What do you mean charges? Suddenly we have fields and charges.
We got a lot of
stuff. We have Santa Claus in their garden. We have everything,
but there's nothing there. We're going to make something out of nothing.
So they say, and then we created something out of nothing. What do you mean out of nothing? I thought you said you had fields, you had charges, you had Santa Claus in there. The whole works. So that's how they do their magic. That's how they create something from nothing, by beginning with something. Okay? And so here we have another fellow, and he says, you cannot measure the length contraction inside the moving reference frame because any ruler or tape you use to measure is also subjected to length contraction, which I talked the other day about. We were talking about special relativity, and I did mention the proper length. And the proper length, the proper mass, the proper time. What does that mean? And I guess this guy didn't understand that. It means that whatever's traveling with you, you measure normally. It's the guy out there, the guy in Cambridge and the fellow over there in Harvard. Those are the ones that are measuring your time, your mass, your length at a different rate or a different value. Okay, but not you. You and your frame of reference, your proper time is normal. So, the guy didn't clarify anything. I guess he just didn't understand what proper length, proper time, proper mass is. And then we have this, and again, all related to the space-time and special relativity, how all this relates to that, right? And here we have another fellow that says, I'm sorry, this is, fellow says, space-time is another name for the ether.
Here we go again.
But somehow space-time waves with gravity. And yeah, he's not the first guy to say this, okay? He's saying something which is correct, which comes out of Nobel Prize winner here, Laughlin, and he said the following: the modern concept of the vacuum of space, which is what all these people say they has nothing in it, but then has something, right? Confirmed every day by experiment, is a relativistic ether, but we do not call it this because it is taboo. Okay, and that's a Nobel Prize.
What do any of those words mean?
Well, the point here is that the fellow is saying space-time is an ether, and that's confirmed here by this mathematical physicist, Nobel Prize winner. Okay, he's saying the same thing. Yeah, it's this. It's
is he just saying space-time is the soup of particles?
No, what everybody talks into double speak because they go in there. On the one hand, they say vacuum. What is vacuum? Well, vacuum is space. So what is space? Well, it's nothing. Okay, and
so far so good.
Yeah. But then they start filling it with all kinds of junk, and they say, well, it's got energy,
well,
it's got fields, it's got charge.
Yeah.
No, because they say, we proved it in the lab. Why? How did you prove it? Well, because we went in there, we separated particles that appear from the void. What do you mean they appear from the void? If they appear from the void, they were there in the void. You can't say that the void was nothing because the particles were there. And the question is, did you rip a piece of nothing? Is that the particle, a piece of nothing, or was the particle there?
They don't know.
No, but it's not the question they don't know. You cannot conceptualize what you're saying.
That too. But what I mean is they see things happening, and then they're like, oh, what must have happened is ABC.
It's the explanation that's irrational. The explanation is irrational. You cannot say that particles appear from nothing, okay? Because if they appear from nothing, means the particle was making up nothing.
Well, that's
and how do you explain that unless the particles are cubic? Then you can say, okay, they're neck to neck, side to side.
Yeah.
Where the vacuum is made of these particles, right? And what happens when you pull a particle out? You leave a hole in nothing? I mean, what are we talking about here? Mm-hmm. So you have to conceptualize it, and they can't conceptualize it.
Yeah.
They just say, particles are from nothing. Okay, we got a problem.
When you get down to brass tacks, at some point you have to explain some missing hole that's being left behind.
Yeah. I mean, when the particle comes in from the vacuum, what did it leave behind? A hole in the vacuum, a hole in nothing? I mean, we already had nothing. Now we have a hole in nothing, which is more or less what a black hole is. A hole in nothing.